We'll start with an address from Edgar Shaghoulian, who is representing the class of 2014. Edgar is from Glendale, California. He received his undergraduate degree from UC Berkeley. We'll forgive him for that. He did his graduate work at Stanford in the field of quantum gravity, string theory, and cosmology with his advisor, Leonard Susskind. And following graduation, Edgar will become a postdoctoral research scholar at the University of California at Santa Barbara. Edgar.
Good afternoon, everybody. Thanks for the introduction. As I stand here today and look at my fellow graduate students and all our loving friends and family, I can't help but wonder, where did this all go so horribly wrong? By some combination of short-sighted decision-making and poor advice, we chose to spend our 20s in labs, behind computers, or at chalkboards, perennially agitated and confused. Our social lives suffered, our egos deflated, and our sense of self-worth crumbled. Our peers pursued high-paying jobs in industry and finance, with bonuses exceeding our yearly stipends, while our bonuses came in the form of free donuts on Tuesdays. When I tell people that I'm a physicist, I get one of three possible responses. The most popular response is to develop a nauseous look of disgust and say, "Oh my God, I hated physics in high school." A markedly different set of people are genuinely confused and ask, "But what do you do all day?" And believe me, think is not an acceptable answer. Finally, a popular new response is, "Oh, like Sheldon." And just like that, we're pigeonholed as arrogant, narcissistic, and emotionally unavailable. All probably somewhat true. But graduate school, rough though it is, has a lot of parallels with real life. For example, take finding an advisor. This is effectively like finding a marriage partner. You date a few different ones to gauge their personalities and interests, you compliment their style, you wonder incessantly whether they like you back, and you never date two at a time. Finally, with sweat trickling down your brow and your heart beating out of your chest, you pop the question to your favorite one. Will you be my advisor? My advisor's response to this proposition was simple. He said, "I'm a terrible advisor. I never know what to work on, and I sure as hell don't know what you should work on. So you'd better just find somebody else." But, like with my girlfriend, I persisted and insisted, and they eventually agreed. After a while, though, you realize what started off as dating and a marriage was in fact your induction into a cult. Your advisor actually has lots of husbands and wives, and has had plenty in the past. You buy into the philosophy and the language, and after a few years, it's all you know. So, why do we do it? Richard Feynman, one of the greatest physicists of the 20th century, would like to say, "Physics is like sex. Sure, it may give some practical results, but that's not why we do it. Maybe we do it because there's an unparalleled beauty to the equations that govern our universe. Or maybe it's the thrill of playing a role in discovering a new truth about nature. I don't know. There are about as many good answers as there are tenure-track positions in academia. So if you know of one, please find me and tell me about it." All jokes aside, for whatever reason, we continue to do physics. We work long hours to help further our understanding of our place and time in the universe. Unfortunately, the funding for this endeavor has been politicized and come under attack in recent years. People, including politicians, are just unaware of the pervasive impact of physics research in technology and economic growth. I encourage all of you, physicists especially, to actively lobby for funding for physics research. It's this sort of work that has always led to surprising advances and growth across many disciplines. When Einstein spent over a decade developing his general theory of relativity, he had no idea that his equations would one day be used in GPS systems. When the heroes of quantum mechanics grappled with the implications of a non-deterministic theory, they had no idea they were laying the groundwork for the modern electronics revolution. The first touchscreens and web pages were developed by a high-energy physics collaboration to manipulate and share data. String theory began as a theory of nuclear forces before the equations unveiled a beautiful framework for studying quantum gravity. The list of unexpected breakthroughs in both physics and technology goes on and on. Perhaps it's precisely this unpredictability that drives so many of us. We don't know the answers beforehand, and nature always has surprises in store. Thank you.